All right. For our next presentation, or last presentation, we have a workshop from Dennis Zollmann from Azero.id. With the title of this workshop is Start Building dApps on Ink. Welcome.
Yeah, thanks for being here. Thanks for all of you joining. It's quite hot, so let's see how the live coding goes. Today I will show you how to start building dApps on Ink. So basically build applications with a front end and a back end on Ink. Who am I? I'm Dennis. I'm a full-stack web developer, full-stack web 3 developer, co-founder of Azero ID, which is one of the first, I would say, full-blown mainnet Ink dApps running on Azero. So it's basically the domain name service on Azero written in Ink. And yeah, but let's maybe start the thing by define what actually dApp or decentralized app or dApp, how please don't say this, means. So it's still a traditional app with a front end and a back end part, but just we aim for as much decentralization on both parts as we can. In the front end, what does it mean? Basically having a traditional front end, but connecting it to the chain, talking to the RPC nodes, maybe decentralized hosting by leveraging IPFS or Arweave or something like that, or using light clients to further minimize necessary trust, which is a very cool thing and very nice doable with Substrate. What does a backend mean in the dApp? Yeah, the backend is the blockchain, and this can be everything from pallets to smart contracts. What I will talk about a lot today, which are Ink-based in pallet contracts and compiled to WASM. And then another thing that can be used for decentralization in the backend is using an indexer network. If you have more complex data queries and stuff, and you don't want to write this all to your very own centralized database. But why? Maybe one more thing. If you're eager to explore this more, I also invite all of you to join tomorrow to the workshop early afternoon, which will probably go a little more into the smart contract stuff of this. I will lean a bit more towards front end and general project setup, how to get started, how to deploy your first contract, talk to it in the front end, and so on. But why actually front-end matters, and that's actually something you have to teach many blockchain developers because they always think contract tech first. But actually I think to onboard the masses to Web3, we need 10 times better UX in our front ends. And this starts, or this even exceeds what we see today in the best Web3 apps, because I think in the future even this stuff has to be abstracted way more. So people should not be even noticed using a blockchain under the hood if you really want to make this usable for your mummy. And especially on Substrate Ink, we need better developer experience to onboard the next wave of front-end developers into the Ink Substrate ecosystem. The current ecosystem or state of the tooling and so on, I will talk about in a minute, is okay, it's getting there, but there's still much potential, and I think we should improve on a lot of points to actually onboard way more developers, both for Ink but also for front-end with Ink. Yeah, and a somewhat unpopular opinion I have, good design and front-end work takes more time than actual contract work. That's something I noticed when developing a mainnet dApp with a team. You always think of the contract as being the elephant in the room, but after you solve this, the box of Pandora, how to design it, how to implement and make it compatible with different wallets and stuff, and optimize UX really for a perfect and very easy flow. Do good communication with your users in the front end with tooltips and so on and so on. So yeah, we will focus on this today. I want to give a short, so to say, ecosystem tooling overview of Ink. This is by far probably not complete, but those are just the most important things that came to my mind on the first site. We have different categories of tooling, contract level. Ink itself is the Rust EDSL, so we have Cargo contract to actually compile it to WASM. We have OpenBrush, so some kind of like the Open Zeppelin for ink with standards for non-fungible tokens and fungible tokens, which are like the two standards mentioned here. For spinning up a local node and deploying stuff, deploying contracts. Oh yeah, that's actually a typo. This should be only supposed to be node. You can use either substrate contracts node, which is like a bare bone substrate node, I would say, with palette contracts enabled. You can like spin it up pretty easily locally and deploy your contracts there. Or Swanky, which is like a tool by A-Star, which is a little bit more full blown. You can also give that a try. For actual contract deployment and interaction, you can also use cargo contract, but I like wouldn't really recommend this. Like using this like beyond playing with your contract. Yeah, of course, like it's a command line tool, and if you have like so to say a protocol consisting of multiple smart contracts with different input arguments for the deployment process, it can get out of hand very easily when you have to write a bash script, which is quite complex and nobody actually can or wants to maintain. There's Drink, which is rather new by the Azero team, which is some kind of terminal GUI where you can like play with the contracts, deploy them with a couple of commands, speak to them, do queries, transactions. There is Contracts UI, which I personally very much like. It's basically a front end in the browser where you can drag and drop contracts. It auto-generates an UI for you where you can see all the functions, interact with them, and like just play around with your contract. That's what like our team used like at the beginning a lot, to like start getting into it. Then there's Polkadot.js apps. I guess you all know Polkadot.js developer console, or however to call it. It can also deploy and interact with contracts. I wouldn't really recommend it only if you are doing multi-sig deployments or multi-sig contract interaction. Then it's the only way to go at the moment, unfortunately. For deployments, like I will speak about this later, my own library is also capable of doing it. When coming to the front-end level and you want to actually build a dApp around your smart contracts, there's basically only like one option out there, which is like the core library, which is Polkadot.js API and Polkadot.js API contract. We try to abstract this away with, there's also copy, but there is also not copy. Maybe there will be copy at some point, we don't know, but this could be like a promising replacement by parity in the future, but definitely at the moment you have to use Polkadot.js. There are two React hooks library. One is use Inc by parity itself. Sam, like the TypeScript wizard behind, is sitting right here. And my library, use Inkaton, which originated like probably already almost a year ago when we like first built our dApp, and there was no other real solution out there to use Polkadot.js in a developer-friendly manner in React and Next.js applications, and from there it has grown. If you really want to have type-safe contract interactions, there are two projects out there which could enable this. Like both come with their advantages, disadvantages. So yeah, do your own research. There is still, I think, the need for something more inclusive, maybe within Use Inc itself. Who knows? And there are boilerplates. I don't know who of you is like familiar with EVM world. There's like scaffold Eve, like everyone basically uses to get started with like basic dApp and contract development in one repository. Something like that is not really, or was not really available for Inc. So I built it myself after participating in hackathons, and like I wanted to get started more quickly, and I noticed there's much potential here to help developers setting the repository up, configuring everything with Inc, with the front end, setting up Polkadot.js or the React hooks library of your choice, making deployments easy, import them in your front end, and so on and so on. That's basically what my boilerplate Inkaton does, and which is also very well, like we'll dive deeper in now in the course of the workshop. I will also do like a live demo of it later, but first I want to speak a bit about its architecture. Like, it's, as I said, like a full-stack boilerplate, and it uses Inkaton, the React hooks library I talked about earlier. But you can, of course, like also like just swap it out with using if you want to. The stack. It's a monorepo with front-end and contract sub-packages. This has shown to be very useful when you're deploying contracts in one package and you're generating, for example, the metadata and also some files containing the actual deployment addresses. You can directly use them, import them in your front end without deploying, copy pasting, updating, and so on. So that's makes this process of iterative development very easy, very useful for a hackathon, but also for production application. You can of course, if you like you can split this into 2 repositories. That doesn't really matter. It's just my preferring. It uses PNPM under the hood, which is very well suited for monorepos, but you can also swap it out with Yarn or whatever you like. It has a pre-configured VS Code workspace, which is a nice file that you can open it in VS Code, and it sets up an editor, some editor preferences for you, with workspaces in mind. So you can define different settings for the contracts package and different settings for the front-end package. Oh yeah, and it has a pre-configured Wurzel deployment, so it's really couple of clicks away to get this live and running after you cloned it and tried it out. In the contracts directory, what do we need to write and deploy, build in contracts? Of course, Rust, Cargo, Inc, Substrate contracts node I mentioned earlier is here for running a local node, and I will show you also in a minute how this is be done. And on top, it has some PNPM scripts that start a couple of services like Contracts UI, Polkadot.js, and also some others pre-configured with the current RPC you're using. So that's actually it just saves you half a minute, but it's still very useful if you're doing it very often. Yeah, and on top, I built multiple shorthand scripts that makes it easy for deploying your contracts, or also for production-ready dApps deploying multi-level contracts, more complex protocols where you have many contracts that depend on each other. You want to interact with them. Yeah, I will show you this in a minute as well. On the front-end side of things, yeah, I'm using Next.js with TypeScript. This might get more unopinionated in the future. Let's see. As of now, I'm pretty convinced TypeScript is the way to go, and Next.js is the easier React in my opinion, because it abstracts so much complexity of bundling, optimizing performance and stuff just the way it just does it for you. There's some basic styling with it, some kind of Tailwind style components, some very basic components like a connect wallet button and interact input fields, but you also can build your own, of course. Then it's using Polkadot.js, as I said, the only option out there right now, and on top the use Inkaton React hooks library, which abstracts a lot of functionality of Polkadot.js away. What is use Inkaton? It's just something a provider you wrap around your application. You give it an app name, a chain, and your deployments, so which is metadata files and addresses. So you can use them everywhere in your code with just a hook, and you don't have to set up your API with your RPC and create your contract instance everywhere again and again and again, which is really saves you a lot of code. Same with the use Inc library. It saves you tons of code. You should definitely use one of those. It has shorthands for gas estimation queries, transactions, deploys, balance fetches. I will show you this in a minute. Constants for chains and wallets, so you also don't have to care about this too much. And yeah, we are using it in production with Azero ID quite successfully. And a lot of hackathon projects have used it already. But as I said earlier, there's an alternative, use Inc. And disclaimer, we might join forces here and in favor of use Inc. So I mean, use Inkaton is working in production very well for us, but be aware that we might move to use Inc at some point. Yeah, already here, doing the live coding session, which hopefully goes well. How to start? That's not too complicated. Go on the Inkaton website, which is the boilerplate, inkaton.xyz. Here you see a basic UI with a basic wallet connection, contract interaction. I will show you this more in detail in a minute. And then to get started, probably the best way is to go to the GitHub Also, you have a very extensive README where you how to set everything up, like also Rust cargo contract, how to start developing a front end, how to start building and deploying your contracts, and how to set up VS Code and your environment, blah blah blah. But actually, it's not that complicated as it looks. It's just quite extensive. So we can start. Wait just a second. I will open this here. So you can just open your terminal and start cloning it. So I cloned a repository, cd into it, and then I can already open my VS Code. And the nice thing it does now, I've written a VS Code extension myself. If you have a code workspace present at the root or present somewhere, it suggests you if you not want to open the code workspace instead of the plain folder, because as I said, it comes with many benefits. I will wait. I will just restart it. I had it open previously. So you can open it as a code workspace. It comes with a lot of benefits. For example, what you see right away, it splits the sub packages of my monorepo on the left. Can you actually see this somehow? Is it readable? So I will keep it at that size probably. Nice. So you see your root, which is the whole project, your front-end package and your contracts package. I have different settings for both of those. And for example, if you're opening a new terminal, it always asks you where do you want to open it, in the root, front-end, contracts package. That comes in very handy, because on monorepos normally you would have to navigate through the packages in the terminal quite a lot. So I will just follow the README now, which is pnpm install. I install the dependencies, and the second step is creating a plain environment file, which doesn't contain much stuff. I can show it to you in a second. So it's basically here, front end, environment local. Yeah, it's more comments than actual environment variables. The most important stuff, or the most interesting stuff here, is that I define the chain I'm gonna use in my environment file, and everything in the front end automatically adjusts depending on what chain I want to talk to. This comes in very useful when you're either supporting multiple chains, or you're switching from your local development node to the testnet node to the mainnet node. Those are all different networks, so you don't want to have so many constants you keep with some contract addresses you must keep up to date. So this is a very straightforward way I found to define this in the environment, and use Inkaton library and boilerplate will adjust. So what next? I just installed dependencies, created the environment, so I can actually go right away and run it. So this will run the front end. And hopefully it works, but it does. So yeah, it's that easy. It was a clone, an install, and a run dev. So you have your own dapp running. To be honest, it's still communicating to a testnet node, because we did not set up a local node yet. But still, you have a full-blown dapp communicating with the chain. And yeah, I will go a little bit more into detail about the UI here. So this shows your balance of the chain currency. This is a nice little wallet button where you can switch between chains. The boilerplate also supports activating multiple chains at once, and you can switch between of them. And it automatically looks for the correct contract instance. You can switch between your accounts, and yeah, it also resolves Azero domain. So that's where you see a testnet domain of connected to my wallet. On the left, I have is the zooming work? Oh, nice. On the left, I have some chain information, name, version, currency, decimals, and some shortcut links. Like I said earlier, you can, for example, click on Explorer, and it directly opens the Poker.js apps with the correct RPC defined. Same with the faucet. If it has a faucet which is available for the current chain, it shows this link. And contracts UI, you can open it. It's also pre-configured with the current RPC. So it's really, you don't have to reconfigure a lot of stuff in the development process. On the right, you see some sample contract that's like integrated in the UI, which is a basic greeter. You might be all like familiar with it. It just stores a string. You have like a function where you can get it and a function where you can set it permissionless. So that's like a greeter contract in Ink. I have like, this is like fetching the greeting and this is update the greeting. So actually we can do this right now. GM workshop. I'm sending the transaction. Ah, yeah, I clicked it. I had to. Whoops, sorry. And transaction sent successfully. Yeah, that's was quite fast. Let's dive into the code. Let's dive more into the like actual project structure. As I said, front-end contracts. Let's start with, I would say, let's start with the contracts. Then we can also like build the contract and run it on a local node. So what do we have here? We have like a deployments directory which contains for each smart contract like the metadata and also the deployed addresses in like files that are named after the chain it's deployed on. That's like just a trick so you can git ignore development TS, because like if you are locally developing and your team is locally developing, you don't want to have merge conflicts on the like actual local node address of your contracts because they differ. You have different local nodes. This is like all created for you automatically if you're using the build and deploy scripts provided within the boilerplate. The greeter is like the only smart contract in here. It's Ink smart contract, which is a Rust EDSL. Here you see like the Ink contract macro at the top, indicating that it's an Ink contract. You see events defined here. You see the storage layout, which just contains a string, as I said. You have two constructors, like one using a default value and one like letting you input an init value. Not very crazy stuff here. And this is the getter I told you about. So this, you can call this to like get the message, get the current greeting from the contract. And this is the setter. So you can call this to update the greeting. This also like emits an event. This comes in handy if you are gonna index the contract and you want to, for example, with Subsquid, have like a database that like shows all historically greeted people, all greeting messages that have been on chain. That's useful to emit events in such cases when you later like want to index stuff. Then we have the tests right within the same file, which is like very cool thing of Ink that you have like first you have native tests also written in Rust, and that's like not like you didn't have this on Ethereum for ages. So and it's in the same file, so it's great to have this co-location. Sometimes it gets a little bit messy if you have very large contracts, but if you have very large contracts, you might have to question your architecture in the first place. So I will actually I will like finish showing you a couple of more neat things. As I said, I have a package JSON even in the contracts directory with some scripts to build tests. They are just calling a shell script. Basically, like building a contract is just like one line of code. So you could like also just use cargo contract in the terminal and build however you like. But this like helper bash script just does like the following. First, you can give it like many contracts and it builds them iteratively, or like it builds them like all after another, and you don't have to like call build this, build this, build this, build this. And second, as I said, it like creates or it takes this like metadata stuff, like here this JSON, and moves it to the deployments directory, which is then imported by the front end. So the front end always knows where the stuff in the contract directory is, and the script just makes it simple so that you don't have to like export it by hand after each deployment, after each build. Sorry. So what can I do now? I open a new terminal in the contracts directory and build. So building life in Rust. What can go wrong?
Is that also a command package JSON where you run
Yeah, you can just pnpm run build. Sorry, yeah, I just wanted to show it's using the shell script under the hood. You can just pnpm run build. So should be finished. Like another script. So it's like finished and now copied the build files to the deployments directory. And another thing you can do here, which is also just a shorthand, is this node function, which basically spins up a local substrate contracts node and in the dev mode on the like default port, and it enables persistence. This is quite useful for development. So you actually have some kind of temporary directory created, which like stores the chain data, and it's Git ignored, of course. And you can like come back a day later and like continue working with your contracts. They still have the same state, and everything is deployed where it like is supposed to be. So actually, I can like just do this. Oh no, I'm always using my short aliases. That's probably confusing. pnpm run node like starts the node. What you then normally do is open another terminal to deploy. But before doing this, I will show you actually the shorthand deploy scripts I have built. This is in the scripts directory. This is also supposed to be extended by you. So if you have like other deploy scripts, if you have like other scripts like changing some contract state or whatsoever, it's useful to put it also here, because you have some utility functions here that like initialize Polka.js for you, some minor types, and then you can like build scripts that look like as simple as this. There are a couple of lines initialization. Setting up the Polka.js API, and also setting up your account. So this is a cool thing. We also have environment files in the contracts directory where you can basically put in your account URI. You can also put in a derivation path even, and then it uses this like account from the environment file to deploy your contracts, interact with your contracts. You want to use this, for example, for testnet or for a mainnet, to use not Alice, because Alice might not have funds there, and also it's probably not the most secure way if everyone knows your secret, your private key of the deployer. So you can put in your mnemonic here. It's all get ignored. It's not fully recommended to do it, but currently there are no better alternatives in my opinion than doing it this way. The deploy script, it's the deployment of the contract itself is like literally 2 lines of code. You get the deployment data, which looks into the target inc folders where the build artifacts have been created by a cargo contract, and then you call await deploy contract, give it the API, the deployer account, the AB, metadata JSON, the WASM code, and yeah, the constructor function you want to call, and then after it's being deployed, you get back an object with the address, the block hash, and everything like of the deployment. And in the like last step, we are writing this to a file. So this is like this file actually I showed you in the very beginning, which is then imported by the front end as well to see like where my contracts are deployed. So if I now do a pnpm run deploy, because we have the local node running, and by default it uses the local node. I could also do like chain, Shibuya, whatever, pnpm run deploy, and then it uses this chain instead. Now I see my contract was deployed under this address, and the deployment info was written into this file. And I don't even have to do much in the front end now, because it's already imported. The only thing I have to do, which I like showed you earlier, is the front-end environment file, which still has aleph0 testnet defined as the chain we're going to use. But now we have a local node running. We deployed our contracts, so we can actually switch here to development. Yeah, there's a file with all the identifiers you can look up. Sometimes what happens now, and yeah, that's happening now, there's one Next.js bug which makes me to reset it once. But after I've done this, I can pnpm run dev in the front end. And yeah, you see I'm connected to the development chain, which I just like fired up. I have a new contract instance here. This is like actually down here, this is the same address which was just printed in our terminal. This is the contract address I'm talking to. I have like a getter of the contract and a setter, and I can just like gm new contract and send a transaction. So who has an idea why that send would not work at the moment? Sorry? Yeah, what is with my wallet? Oh no, my wallet is connected. Sorry, like it's like here, connect wallet. It's like I never really showed you this step because it's automatically reconnecting, and I connected before the workshop. So yeah, what?
Why won't that work?
Why wouldn't that work? That submit. One idea. It's like actually here, because I just like started a new local node and my account has no funds on that local node, so I cannot pay for gas. So, but the UI is like clever enough. It says you in sufficient balance to pay for fees. It even offers you to like go to the faucet if it knows that the current chain has a faucet. The faucet in this case is Polkadot.js apps. So I can go here. I can ask Alice, please, Alice, give me 100K, and I'm happy. Yeah, and Alice was very generous. Now you see, like it's live updated. The balance is watched, so you don't have to refresh the page even. Sometimes you have, but I don't know why. Just doing it in case. Now I can try a GM workshop, call it, bam. So it's like set. Not for that. So wait. One thing I want to like show you a little bit more, yeah, we have some time left, is like how the front end is set up. That's like not too complicated if you're like familiar with Next applications. It's basically yeah, we have Tailwind in here, we have Prettier, ESLint, Stage, like all this stuff pre-configured, which comes in handy. You can like disable it, of course, if you don't want it, but it's like already somehow like production level stuff here. So like you really can start using this boilerplate and write like the next big Web3 startup. In terms of front-end code, like I've like showed you earlier, this is the app file, which is like the entry point somehow. I have this wrapper around my application, which is the use Inkaton provider, and then in the app, in the index page, you see like again like for like we have this header, we have this and this. So here's the title. Here's the connect button with the balance. I can have a quick look. It's using use balance, one hook by use Inkaton, and it has the watch flag set to true. So it like updates automatically what I just showed you. Wait, I'm a little bit lost. Ah, yeah, okay. So here we have the chain info, which is like this little box displayed on the left. It just like fetches some metadata and prints it out. Also, all with mostly with the like plain Polkadot.js API. So like very important, if you use Ink or use Inkaton, you're not like losing all the Polkadot.js stuff. It's just like an abstraction on top. And if you want to use the API promise, you can at every time and just do like normal API dot whatever. In this case, like I'm getting the chain name version and some properties here. And the right box is the greeter contract interactions component, which I will also show you. We actually have time for this. So we have two functions here. One is fetching the greeting, but that's like only like some loading states, some checkers. The like two important lines are here. Await contract query with use ing it would be use call, and then decoding output with use ing it would be pick decoded. And updating the greeting is the same. You just use like contract tx function. There is like one caveat here. You maybe have seen like those nice little toasts at the lower right. So I wrote like just a simple wrapper around contract tx plain function. So we see like a success message, we see an error message, we see like a loading indicator when the transaction is running. So this is just like a little extension you don't even need, but of course for a good UX I would recommend doing so. And here, that's like really just like, it's using Chakra UI, but you also don't have to use this. I've just found like for hackathons, it's very useful. You don't have to like spend so much time styling. You can just use pre-made components and like focus on the rest. So this is what I used a lot during hackathons. This is the fetch box. So this is this thing. And this is the update box with an input field and a button submitting it. And yeah, the contract address at the very bottom. So nice. I have some time left to actually show you like an extension of this. Like I want to like further develop the contract and the UI together with you. And what I'm gonna do is adding a function to our greeter contract, because wouldn't it be nice to have a function that reverses the string? Yeah, it would be. So we are like gonna add this here. It's like super basic. It's like a inc message, reverse message. It probably uses the most elaborate way possible in Rust to reverse the string. Yeah, just Stack Overflowed this. And of course, like we wouldn't be a real workshop if we like wouldn't test the functions we are adding. So we are adding like a nice test and check that the reverse string function is actually working. By the way, a nice thing, you can even run those tests inline in VS Code, which is super cool. What I need to do now, after I've changed the contract, obviously, I have to rebuild it. And that's what I do now. That should be a bit quicker than the first time, and it was. So now I built my new contract. Of course, I changed the contract, so I also need to redeploy it if I want to use it in my front end. So pr deploy another time. It's writing the greeter under a new address, which is automatically already imported in the front end because it's like importing it from the other package. And yeah, but of course now I need also some front end to like call the reverse message that you can actually see what's happening. I will do that in a second. First, I will add a function that actually reverses that calls the transaction on chain to reversing the greeting. So you see here, contract transaction with toast, basically the same as above, just with a different function name. It's now reverse message. That's like it's like always like you have to change this casing to this casing, but that's how it is. We are looking for more type safety with contracts at some point as well, as I said. And we need a button that calls this function. So workshop snippet 2, saved. So now we see reverse greeting. I just like gonna double check. We have like 5HF, and is this the one I just like deploy? Maybe I need to refresh. Yeah, now I see 5GU. I needed to refresh the page once, and that's also the one we just deployed. And now we also see like it's not GM workshop anymore because it's a new deployment, it's a new instance, new state. So that's again the initializer value, hello inc. And what we do now, we call the reverse greeting transaction, and hopefully, yeah, hello inc is reversed, so we can try it again. And yeah, it's like in the correct way again. So yeah, that's the live coding part I wanted to show you, and the little extension that worked smoothly. I'm super happy. Let's get back to the very last slide. So what's next? As I said, we might like join forces with useinc and combine the best two parts of the libraries and like don't have like tooling fragmentation here. A big like thing on my roadmap, besides like pushing the boilerplate further, improving it, making it easier, making it less opinionated, is building an actual CLI. So my plan is to do the create inc app. I don't know like how many React developers we have in the room, but it's like create React app, but create inc app, and you have like a nice CLI asking you a bunch of questions and setting up your project right away in the structure I just showed you. And of course, more education docs, examples, as always. Give it a try on inkathon.xyz. Please open issues, join the Telegram group, also join the Element Use Inc group. We are always happy to help and see actual projects being built with Inc. And yeah, let's fuel the next wave of Inc dApps together. Thank you.
Do you have any question to Dennis? Yeah.
Hello.
Hey.
Yeah, it's more of a practical one. Is there like, are there any install requirements for this workshop tomorrow that we should know about in advance?
Some requirements for the workshop?
Yeah,
Sam, I don't think so.
For the game,
Yeah.
get some ROC tokens for Rococo, have a wallet, and if you want to install a carbon contract and get that set up ahead of time, that would save a lot of time.
Yeah. So for those who haven't heard, set up a wallet and get testnet tokens from Rococo.
Inc, cargo contract, and get some Rococo.
Yeah, and you want a browser wallet, have that set up.
Cool.
Because we're going to be interacting with contracts UI, and you'll need to deploy your contract.
Yeah, so have a
So for those
browser wallet set up, and your account set up, so you can connect your wallet and then actually deploy a contract. Because you're going to have a player contract that's going to be part of the game contract. Everyone's going to submit their own contract.
So if you don't have a compatible wallet yet, we have like a very elaborate documentation on this in our Azero ID documentation, how to create a wallet and get faucet tokens. Not Rococo, but that should be easy for you to figure out. Great. More questions?
I have the microphone already. So I wanted to, it was more of a comment. That's awesome. That was the best tour I've seen. I've looked at the code in the past, but I think I want to compliment you, and I think it's a great example of people building practical libraries for developer experience, and not just decentralization and cool multi-sig. But this is like, there's a lot of practical things that you thought about, and it's like a full developer experience, and that's going to bring more developers into the ecosystem. Can't wait to use it. I think it's awesome. So good job.
Thank you very much.
When you spin up a node, is it like a generic that could support any parachain?
Like if the parachain supports the pallet contracts, then you can actually deploy in contracts there. But the local node I spun up was actually like agnostic from any parachains. It's just like a bare bones substrate node, but without most of the pallets, but like especially with pallet contracts enabled. So answers that your question?
Yeah, thank you.
Nice. You can also use Swanky as an alternative, as I said. Or you can run any parachain node locally also if you want. It's just like an overhead you normally don't need for developing contracts locally.
I have another question if no one does. You mentioned also there was a decentralized indexer in the tech stack.
Yeah, it's like, I think they are like still not fully decentralized, but I know they are like working on decentralize all aspects, which is Subsquid. They are like building, launching a network at the moment. I'm not like, check it out yourself. Subsquid or the other indexing solution available is Subquery. So compare them.
Thank you.
Okay, if we don't have any more question, yeah.
Hello. So if you want to add a new contract, you will need to like add a new folder.
Exactly. Let me show this really quick. Like what you need to
and
do.
then in the build all.
Exactly. Yeah, you already know it. Like why are you asking?
But then my question was the last step. Like if you want to set different parameters, like from one contract to the other one. One script that do like.
You can like do it however like first, as you said, like new directory with a new Rust file in there. Then update your build script, just like add another parameter in this array, and then in the deploy script, just like have a second deployment, and then you can like take whatever you get from that first deployment or do whatever you want in between and put it in as like constructor arguments here. So that's basically how to. And then like one other thing you have to do, which I didn't show, I think, is the deployments file in the front end, which also like needs another instance in this enum and another item in this object. But this is described in the README how to add a new contract.
Great. And when you grab, like when you use Ink Hackathon, like in the main page, you put like all the contracts.
Exact. Oh yeah, that's actually a nice thing I didn't talk about too much in detail. So one thing, I have this function I just showed you, which is like get deployments. It like gets the, depending on what chain, what network you are asking for and what contract name you are asking for, it gives you like an object with the contract ID, network ID, address and metadata. And then I put it into the provider like at the very beginning as some kind of registry. And then if I want, in some part of my app, if I like, if I want the instance of a contract, I don't have to import like everything again, like address, metadata. Like this is like normally a couple of lines of code, but in this case you just do use registered contract, put in the ID you gave the contract, and then you can like get it with one line.
Thank you.
Okay. Huge thank you to Dennis. Thank you very much.
Yeah, thanks.
Okay. That's it for the day one Sub0. The Polkadot Developer Conference 2023. We have another packet day tomorrow and kicking off with check-in at 9 a.m. Make sure to get here early to get your seat in common space. Thank you very much.